So extreme value theorem says that every continuous function defined on closed interval has both absolute maximum and absolute minimum. Both absolute maximum and minimum. So here is a quick strategy to find absolute maximum and minimum if your function is continuous on closed interval. The first step, you want to find some candidates for extreme values. One good candidate is critical number. So in step 1, you find critical number. So those numbers C will be candidates of absolute maximum minimum. In step 2, you evaluate f of C for critical numbers that you found in step 1. You also compare function values f of A and f of B. And in the last step, you pick or choose largest value for absolute maximum, smallest value for absolute minimum. So for example, we have in this figure critical numbers, say C, D, E. So we have 3 candidates from critical numbers, and in step 3 you consider 2 endpoints as well. So far we have 5 candidates, and then you pick largest value for absolute maximum, smallest value for absolute minimum. So here is a good example to apply the previous strategy to find absolute maximum and absolute minimum for this function defined on closed interval -1 through 4. So first step is to find critical numbers. So to find critical number, you take derivative. From the first term, we have 3x squared, and then from the second term, we have -6x, and this constant term will be gone. Okay, you want to find where this derivative becomes 0. Basically, you solve this quadratic equation, and you can use common factor, which is 3x. What's left is x minus 2. So that means we have 2 critical numbers. One is 0 and then 2. In step 2, you evaluate f of 0. Well, if you plug in 0, we have 0, 0, and then 1. And f of 2. If you plug in 8 minus 12 plus 1. So 8 minus 12 plus 1 is -3. So this is step 1 and step 2. So in step 3, you also consider 2 endpoints, -1 and 4. You evaluate f of -1. So -1 minus 3 plus 1. So -3. And f of 4. So 4 cubed minus 3 times 4 squared. So 64 minus 48. So 16 plus 1, 17. So far we have 1, 2, 3, 4 candidates. And you choose largest one for absolute maximum, smallest one for absolute minimum. So step 4. F has the absolute maximum, which is the largest one, f of 4, and absolute minimum. Well, those two function values happen to be the same. So f of 2, f of -1. Actually, if you take a look at the graph looks like this. So f of -1, f of 2 has the same value, -3. and then f of 0 is 1, and then f of 4 is 17. So the graph looks like this. So those two values gave us absolute minimum, -3.